Hello, and welcome back. PySpark supports use of SQL statements for data preprocessing. For that you need to be familiar with SQL. We are going to discuss few basic SQL statements to work with our dataset. First we create a Spark session, load the trip and fare data as before. We can check the schema of the dataset using print schema command. Now, to use SQL statement, we have to register the dataframe as a temporary table. To do that, dataframe has a method called create or replace temp view. It takes argument as the table name you want to give. We are now ready to perform SQL operations in Spark environment. Select statement. Select specifies which columns in database tables to include in the result or result set. Star after select indicates to select all columns. Limit is used to limit the number of records returned. Limit of 20 means retrieve 20 records. Spark allows us to create the query string and then pass to Spark SQL method. As shown, we select all columns and 20 records from our table named trip. The output looks like below. Now, if you want to select a column from the table, specify column name instead of asterisk. Here we select column name, medallion. What if you want to select multiple columns? It's simple, specify column names separated by comma as shown. Let's put some conditions to our statement. For this we use where clause followed by condition. Here we are putting a where clause on trip_distance greater than 2.3. As shown, it will return the records where trip distance is greater than 2.3. Count clause. The count function returns the number of rows that matches a specified criterion. The syntax is, you specify count and within parenthesis you specify the column names or star for all columns. As shown, it returns the total count of the number of records present in the table. We can use count with some condition. In that case, the output returned by the condition is passed as argument to count. So, we want to filter records with tip distance greater than 2.3. Then the result is passed to count. Count calculates the number of filtered records and displays the result as shown. Distinct. The select distinct statement is used to return only unique values. As shown, we use select and then distinct followed by column name. It will return all distinct records in that column. In our case it is trip distance. Order by. The records returned by SQL query is not guaranteed to be in any order. Only way to make sure they are in order is by the use of order by clause. We can specify either ascending or descending. Order by works on the column name. If multiple columns are selected to order, then the result set is sorted by the first column, and then that sorted result set is sorted by the second column, and so on. In this example, we are sorting the entries of column pickup datetime in descending order.
Aliases. Aliases provide database administrators, as well as other database users, with the ability to reduce the amount of code required for a query, and to make queries simpler to understand. In addition, aliasing can be used as an obfuscation technique to protect the real names of database fields. You can alias tables and columns. We can use alias to temporarily assign another name to a table or column for the duration of a select query. Assigning an alias does not actually rename the column or table. The way it works is as shown. After table name, you just specify alias name. This name will then become alias or correlation name for further usage. You can also use AAZ clause for better readability. Once alias is defined, the way to access the column of the table is through dot operator. Alias name dot column name. Here is an example shown. Cross-joint. A cross-join is a join operation that produces the Cartesian product of two or more tables. Cartesian product is the set of all ordered pairs between two product elements. Let's say we have a table, A, with three elements 1, 2, and 3. And table B with elements X, Y, Z. Then the Cartesian product or cross-joint will give 3 cross 3 9 elements combination. The result will be a table with flattened 9 elements table as shown. Now to get the cross-joint between our two tables, trip and fare, we create a cross-joint query. The result is as shown. Let's now execute a complex statement with multiple conditions. We select common columns in both the tables first. Then we apply multiple conditions using an operator and equal to operators. In one shot, we can filter out, combine multiple tables using SQL. We have seen similar operations on data frames in past videos. This brings us to end of this course in PySpark. Hope you have enjoyed the course materials and practiced the sessions to get hands-on. We will have course on Spark ML and Spark streaming in big data space. We have advanced course on ML algorithms, DevOps, IoT, MATLAB and many more.